A very good morning, children. So today we are going to continue our chapter 3, Understanding Quadrilaterals. Today I want to extend the same introduction concerning the concept of polygons. So which is actually we are discussing. So polygons. So as it's been discussed that a simple closed curve made up of only line segments. Okay, simple, it must be a simple and closed and curve made up of, so simple closed curve made up of line segments. Okay, purely line segments. It should not carry any kind of curve like structures. Okay, such figures we call polygons. So just I want to give you some examples. So curves that are polygons, curves that are polygons. Don't copy anything from this into your CWs. I will send you a document which is to be copied. Okay, curves that are polygons and curves that are not polygons. Curves that are not polygons. So from the definition of the polygons, we are very much clear that they must be simple in structure and closed and curved with line segments. So if I am going to draw a polygon like this, okay, it's actually coming up like a curve, but it should be a line segment. So look, so these are simple and closed, because if we take the starting point here, we can end up, if we go our path like this, and we can come back to the same point again. So if we take this one as the starting point for this figure, so if we start like this and if we continue our journey throughout this way, we can come back to the same point again. So curves that are polygons means they must be simple, okay, closed, curve and made up of line segments. Now curves that are not polygons, I'm just giving an examples. Look, okay, so this is an open curve because it is not at all. If we take this one as a starting point, we will end up somewhere here by taking our journey throughout this way, and things like this. Okay, so even this is also a polygon. I mean the curves which are not the polygons. Hope you are quite clear with this. Next we are going to discuss about the diagonals of a polygon. Very important concept. So now the diagonal. For any polygon, if there exists a line segment which connects two non-consecutive vertices, this one is important, non-consecutive, or we can say that means the vertices should not be adjacent to each other. Okay, the vertices should not be adjacent to each other. For example, let us take a polygon like this. Okay, a polygon. So let us mark it P, Q, R, S. Okay, so the vertices of these polygons are going to be vertex P, vertex Q, vertex R and vertex S. So in this polygon or in this quadrilateral or in this rectangle, we can say that P and Q are consecutive side by side. Q and R are consecutive pair of vertices. R and S a pair of consecutive vertices. S and P or P and S pair of consecutive vertices. So now non-consecutive vertices means if we take P, R is the non-consecutive vertex of P. That means it is not side to it but quite opposite to it. Okay. Similarly, the non-consecutive vertex of Q is going to be S and the non-consecutive vertex of S is going to be Q. So now if we join such non-consecutive vertices of the polygon using a line segment, for understanding I am drawing the dotted lines. Okay. So if we join that non-consecutive vertices of any polygon, such line segments we call diagonals. You already learned this in your previous classes. So for the quadrilateral or polygon PQRS, the diagonals are going to be PR. Okay, PR a diagonal representing as a line segment, and SQ or QS. SQ or QS. Okay. If you write PR, you should not write RP as a diagonal again. Please be careful. Okay. Because both are the same. Similarly, for QS, you should not write SQ. Either you have to write QS or SQ only once. Hope you are clear. So, the line segments or the line segment connecting the non-consecutive vertices of a polygon are called as diagonals. Okay. This is the very basic introduction to this chapter, children. The next part actually deals with the topics that are to be covered in your 8th class. So please be attentive. Very confusing topic. So please keep your focus over here. So the next concept is convex and concave polygons. Okay. That means we are going to learn how to identify a polygon as a convex polygon or a concave polygon. Okay. So before that, if you check the screen, there exists a variety of polygons which we can identify in our daily lives. So these are the different ways where we can observe different types of polygons on a daily basis. Hope you are quite clear with this. Now we are going to identify the basic differences which we have to observe to define a polygon as convex polygon or a concave polygon. Okay. In your textbook actually they gave only one major difference, but I can say you there exists 3 characteristics which we can observe in convex and concave polygons, in which the first one, okay, the first one is actually pointing to angles. Okay, first one pointing to angles. So the second one actually pointing to vertices, and the third one we can use the sides of a polygon to define whether they are convex or concave polygons. Okay, using angles of the polygon we can identify whether the polygon is convex or concave, or using the vertices of the polygon we can define whether it is convex or concave, or using the sides of the polygon we can define whether the given polygon is convex or concave. Any one of these can be used or all the 3 can be implemented to differentiate the convex and concave polygons. Now based on the angles, please observe the board very carefully, children. Based on the angles I am discussing, so based on the angles, in a convex polygon, all the internal angles or the interior angles all the internal angles will always be less than 180 degrees. Please keep this in mind. If you observe, in a given polygon, if all the angles are less than 180 degrees, we can say such angles or such polygons as convex polygons. I am giving an example. Look. So I am taking a triangle like this. Okay, for instance, let us take this as an equilateral triangle. Okay, as you know, in an equilateral triangle, all the sides are equal. So ultimately, we can say that the internal angles of these are going to be 60 degrees each. Isn't it? 60 degrees, being an equilateral triangle, all the angles will be of measure 60 degrees. So ABC triangle, for example, all the internal angles, okay, angle A is less than 60, which is equal to 60 degrees is less than 180 degrees. Angle B is 60 degrees here, which is less than 180 degrees. And similarly, angle C is equal to 60 degrees, which is even less than 180 degrees. Okay, usually we won't get these problems in triangles. So if all the internal angles of a given polygon are less than 180, we call such polygons as convex polygons. Okay, now let us take, I hope you got the point now. If all the angles are less than 180 degrees, we are calling convex polygon. If at least one angle, okay, if at least one angle of a polygon is greater than 180 degrees, because here we got less than, isn't it? So it is quite easy to keep this thing in mind. If at least one angle is greater than 180 degrees, we call such a polygons as concave polygon. Here all the angles will be less than 180 degrees, whereas here one angle will be more than 180 degrees. Please observe the board carefully. So I want to give you an example for the same. So look. So the possible vertices I am writing starting with A, B, C, D, E. Isn't it? So in this polygon, it is very much clear that this is a polygon because it is simple and closed and formed by the line segments. So in the polygon A, B, C, D, E, observe this angle. See, here this angle is internal angle only, isn't it? Okay, interior angle only. Now, if we try to check what the angle of this polygon is going to be at the vertex D, see, 180 degrees means straight line, isn't it? So I am drawing a straight line across this. So if this measure is going to be 180 degrees, then this extra angle is definitely going to be added to this, which is definitely greater than 180 degrees. So here we can say that angle D in the given polygon is greater than 180 degrees. I hope you understood this, because 180 degrees usually we will take like this. Okay, so this part actually gives us 180 degrees. Then here we have some extra angle here and extra angle here. So through this we can say that angle D is going to be definitely greater than 180 degrees. So the given figure is going to be a concave polygon. I am repeating again, children, very important definitions. So for the given polygon, if all the internal angles are less than 180, we call such polygons as convex polygons. And if at least one angle in the given, one angle, interior angle here also, so if at least one interior angle of the given polygon is going to be greater than 180, what actually we call it? We call such as reflex angles, isn't it? When an angle is going to be greater than 180, we call such angles as reflex angles. So if one angle is going to be a reflex angle that is more than 180 degrees, we call such polygons as concave polygons. So I want to stop the concept here. So tomorrow I will discuss how to check the given polygons as convex and concave by using the vertices and the sides. So that's all for today. I will send you the notes what exactly to be copied. Have a great day.